Hey everybody, welcome back. This is your first cyber lesson for Algebra 2. Going to go through some short, brief notes with you, give you a few examples, and give you a short assignment to do, and also send back to me after you complete that. And then I'll give you some feedback on the problems, hopefully figure out anything we need help with, and we'll offer office hours probably Thursday, Friday morning to help you out live if we can. So I've included this attachment. I don't think you need to print it out, but at least you can see it on your Chromebook, whatever you've got. And we're going to be doing some properties of exponents. And if you recall, we did this back in the early winter. We did exponents where we learned how to, product of powers and negative exponents, zero exponents, and you all did fairly well with that. But now we're going to a point where we have fractional exponents. And I have to do the same kind of operations, whether it be add, multiply, divide, zeros or negative exponents. But now they're fractions. So before we actually get into the details of this, I do want to go over some fraction work with you. So take yourself back maybe to, sixth grade, maybe learn some fractions. And perhaps you learn to add fractions. Now you can remember if you added a half plus 3 halves, when you're adding fractions, you had to make sure you had the common denominator. So you had the 2's here that add up. So we could just it'd be 1 plus 3 over 2, common denominator, which would be 4 over 2 or just plain old 2. But when you add or subtract, you've got to have the common denominator. So that's, I think, should be straightforward enough. Now, if you're adding different denominators, let's say you're adding 1/2 plus 3/4. Well, the 2 and the 4 aren't common, so you have to get those to be the same number. And we got to find a multiple of 2 and 4, and that's going to be 4. So we got to multiply the 1/2 by 2 over 2, which is just 1. And we make that first fraction now going to be 2 over 4. Because 2 over 4 is still 1/2, it's just not simplified. But now we have the 4 as a common denominator with the second fraction, and now we can add those up. And then when you add up fractions, you keep the denominator, it's still 4, and the 2 and the 3 become a 5. Okay, now multiplying. Sometimes folks have a hard time visualizing what's happening when you're multiplying. But let's say I want to do 1/2 times 1/4. And I want to know what that equals. Well, what are we doing when multiplying? If you recall, the multiplication is, we're trying to figure out what part of the second fraction is the first fraction. So we want 1/2 of 1/4. So if you're struggling with it visually, if here's a quarter, here's a quarter, right? Well, we want half of that. So we want to cut that in half. Well, hopefully you realize it's an eighth. So to get that, multiplying is actually easier than addition. You just multiply numerators and denominators. 1 times 1 is 1, 2 times 4 is 8, and there's your answer, 1/8. So multiplication is a little easier than addition. So I just wanted to review those with you quick because some people forget some of the basics with that. So now let's go to our lesson 6.2. And here's a whole bunch of examples. When you multiplying the same base, you add the fractions. So the very first one here, you're multiplying with the same base, which is the a, and you add the fractions. So they have 1/2 and 3 halves. In common denominator, they add up nicely to get you 4 halves, which is 2, which is kind of my example I gave earlier. When you're doing exponent to exponent, number 2 here, you multiply those. So you basically multiply the m times the n. So in their example, they have this 2 times the 5 halves. Well, it's 2 over 1 times 5 over 2, and that's going to end up getting you just plain old 5 over that 3. So again, I'm just reviewing things you probably already know. Also, when you have different bases, this is number 3, you just distribute the exponent to both the bases. There's a and b, and they both have that m now above it. And what else we got? Oh yeah, negatives. whatever you have for negative, you push it from numerator to denominator or vice versa. That's shown number 4. Number 5, oops, okay. On 5, when you're dividing with the same base, they both have the a base, so make sure you notice that. You bring the denominator up to the numerator and subtract it, so that's there. An example this shows nice. The 4, the 1/2 on the bottom, you bring it up and subtract it, and they both got the same denominator. So it's 5 minus the 1 over 2, which is then 4 over 2, which is just plain old 2 as the answer for that one. And lastly, when you have a fraction with different bases and you have an exponent, you distribute that to both the numerator and denominator equally. And if there's multiple bases in both of those, you distribute it to those equally as well. So that should be familiar to things we've done in the past. So let's look at some real examples. So example 1, using properties of rational exponents to simplify an expression. So the first one, A, we're multiplying 1/4 and 1/2. They both have the same base of a 7. So it's going to be 7 to the 1/4 plus 1/2. And as I showed earlier, you can't add those straight up. You've got to get a common denominator. I know that 1/2 is going to be 2/4. So this is 7 to the 1/4 plus 2/4, which equals 7 to the 3/4. So you're applying your exponent knowledge with your fraction knowledge and doing some wonderful things. Letter B, you're distributing the 2 to the different bases. You got a 4 and a 6 base there. So you got to distribute to both of those. So it's going to be 2 times 1/2, which is going to be 6, 2 over 2, times 4. And the 2 times the 1 is over 2/3. And at this point, we're just going to leave it at that because all they want you to do in these is simplify. We're not going to totally evaluate these all the way to the end. So that's simplified enough for now. Well, I guess make it further. It should just be 6 times 4 to the 2/3. And for now, that's fine. Okay, next thing we got here is different bases with this negative 1/5 fraction. So I'll just multiply that negative 1/5 times the 2 exponents, the 5 and the 5. So I have 4, and this is going to be 5 over 1 times negative 1 over 5. Again, these are the exponents. Times 3 to the 5 over 1 times negative 1 over 5. And I'm writing all that out so you can see it. So the negative, this all becomes 4 to the negative 1 times 3, taking a negative 1. And where do those things end up going? They end up going down to the denominator. Oops. So we'll just move that down. That'd be 1 over 4 times 3, which is really 1 over 12. For letter D, and this is a good one here because you see the 5, the two common bases, the 5 in the numerator, right here it is, the 5 in the denominator. They have the same base, but there's no exponent for the 5 in the numerator. So what they do is you stick a 1 there. So now you have a 5 with a 1 and a 5 with a 1/3. Now you sort of see the exponent value of it. So you can bring this one up here and subtract it. So you can have 5, 1 minus 1/3. Remember, you subtract when there's division. And we know 1's going to be 3 over 3, but let me show you. So this is going to be 5. So this is going to be the exponent 3 over 3 minus 1 over 3. And that then becomes 5, 2 over 3 as your final answer. And the last one, I'll skip this one for now because I think I gave you enough there to work with. So here's a little homework for you. If you go down here, just a couple problems. And then we go over these in our office hours later this week. So skills practice. If you can try a couple of these out, take a picture for me and send it to me by Friday. I'll look at these. I think if you could just do numbers 3 through 10, that's 8 problems. I'll look those over. We can talk about it. You can ask some questions. We can just shoot the breeze a little bit since we haven't talked to each other in a while also during that session. But that'll be posted for you for Thursday and Friday. All right, folks. Good luck.